Hello, welcome to the case against fracking. My name is Martin Porter and I'm an environmental campaigner. I have been for slightly more than 20 years. Over that time I've been Swampy's spin doctor and shared a police cell with Lord Peter Melcher when he was head of Greenpeace UK. I currently campaign for the Manchester Greenpeace Network and Frack Free Greater Manchester, but the views in this presentation are entirely my own and not those of either of those organisations. Among the things I've done recently is organise this event in the picture, the United Against Fracking March in Manchester in November 2016, led by Bianca Jagger, which we think, or at least we claim, is the largest ever gathering against fracking in the UK. I also have a degree in astrophysics. Anyway, on with the presentation. What on earth is wrong with fracking? Well, first of all, I'm not going to say very much about what fracking actually is. There are other places you can get that information. The Talk Fracking website has some very good stuff for a start. All I'll say very briefly is that fracking is a way of getting oil, or more usually gas, out of impermeable rock. Conventional oil and gas operations, the hydrocarbons are impermeable rock. You drill a hole and then it's just like drinking through a straw, you suck the stuff out of the pipe. Fracking, you have to first of all blast in high pressure fluids to crack open the rocks, and then sand mixed in with the fluid keeps the cracks open, allowing the gas to be sucked out. It is an intensive industry, meaning your wells need to be no more than a mile apart, and that's one of the things we're going to come to. Fracking operations involve lots and lots of wells. Now this picture here shows some of the theoretical risks of fracking. I'm not going to talk too much about theoretical risks. What I want to look at is what are the real risks and what is the real evidence in the real world of these risks. And I'm going to cover a number of areas during the presentation. Now what we're going to find as we go on, as we move down the list, the seriousness of the impact goes up. But at the same time it becomes more difficult to get the evidence. So whilst we know pretty much what a fracking well looks like, proving whether it contaminates your water is much more difficult. And that's the problem with looking at the real world. Evidence is hard to come by. So what does a fracking well look like? Well, this is the iGas test drill at Barton Moss in Greater Manchester. Not a frack, it was just a bit of exploration. There was not all the equipment associated with injecting the high pressure fluids. Also the rig is a bit shorter than an actual production well would be. But it gives you some idea of what they look like. Now Grant Shapps, when he was chairman of the Conservative Party, said a fracking well is about the size and shape of a domestic house. If he meant something with a 125-foot tower covering the area of the football pitch, he was probably right. That's a little bit bigger than my house, but then I'm not the chairman of the Conservative Party. And the thing you have to remember is, we're not just talking about one well here, or even a dozen. To actually get fracking off the ground, you need at least 100 wells. To actually get fracking making us energy independent, or at least gas independent, you would need thousands of wells. Now, that's rather hard to imagine. There simply isn't the space in the United Kingdom. But what you have to imagine though is something a bit bigger than this, scattered across the countryside, every mile or so a well. Clustered into pads of maybe 6 to 10 wells, but covering the countryside. The industrialisation of the English landscape. That's one of the reasons we don't like fracking. But if Barton Moss gives you an idea what a fracking well looks like, it certainly doesn't tell you what one sounds like. Now this is Baron Howell of Guildford, George Osborne's father-in-law, the former Chancellor of the Exchequer, and he was a Tory energy minister. He was the one who came up with the phrase the bleak and desolate northeast, suggesting that there were huge parts of the north of England where nothing much was going on, and you could land a couple of hundred fracking wells without anyone really noticing. Then he went to the United States to see what fracking was like for himself. And this is one of the things he said. He also came back and said this is electoral suicide for the Tories, or at least it's electoral suicide if you do it in the part of the world where you are more likely to vote Tory, which probably explains why very few areas of the south and large areas of the north have been licensed for fracking. And I'm not the only one who's noticed that the map of licensed areas rather more closely matches a political map of the country than the geological map. But anyway, if the noise and the sight of a fracking well can certainly annoy you, is there any evidence that fracking can actually harm you? Well, yes. And if you want hard evidence that fracking is actually dangerous to you, look at this issue: road traffic. Fracking operations take place in rural areas, accessed by narrow rural roads. fracking well will be in place for no more than 5 years, possibly less. That's not enough time to make it worthwhile building bigger roads and other infrastructure to deal with the large lorries that come and go. And there will be lots of large lorries coming and going. Up to 109 movements a day and 10,000 in total for each frac. That's a lot of large lorries on a lot of small roads. Now then, in Texas, an area that's been very big on fracking, road traffic deaths have been going down generally over the last few years, as they have been in most developed countries. But in the parts of Texas where fracking's been going on, they've been going up. And I think the picture shows you a clear reason why. Of course, getting actually hit by a truck is probably rather unlikely. Rather more likely is noise, traffic congestion, everything that goes with that. And so one reason we don't like fracking is it will cause serious traffic problems. That Newcastle study quoted there said these problems increase exponentially as the number of fracking wells in the area increases, what they called a non-linear response. But anyway, on with the list, and we come to earthquakes. The one thing everyone knows about fracking is it causes earthquakes. And here in Oklahoma, they've had a lot of earthquakes recently. This is also a part of America that's been heavily fracked, and they've certainly felt the earth move. Now then, earthquake scales are a bit complicated, but basically from magnitude 3 onwards you notice it, really notice it, and from magnitude 5 onwards your house notices it. Some of the bigger earthquakes they've had, I think they've had a 5.7, caused $1.5 million worth of damage. So, earthquakes, yes. Were they caused by fracking? Well, yes and no. They weren't actually directly caused by fracking. What they're caused by in Oklahoma was the re-injection of waste fracking fluid down the holes. So, yes, earthquakes have caused a problem in Oklahoma, but there's quite a simple solution. You don't re-inject the waste fluid down the hole. But is that the whole story on earthquakes? Well, no, it isn't. Because if you move north of the border to Canada, you find Alberta, an area which never really had many earthquakes, but now has quite a few. And the geologists have studied it, and their conclusion here is different to the conclusion in Oklahoma. Yes, here the earthquakes, or at least 90% of them, were caused directly by fracking. Not quite as big as the Oklahoma ones, none that are over 5, but certainly ones that are over 3 earthquakes that you would notice. So, yep, Oklahoma, not really. Alberta, yes. The United Kingdom, what can we learn about United Kingdom? Well, not a lot because it hasn't happened yet. But this is the story so far. One high-pressure frac carried out in the United Kingdom, causing a couple of earth tremors and one well failure. This was at the Quadrilla Resources site at Priest Hall in Lancashire. Now, the well failure wasn't really much for you or I to worry about. It happened about 15,000 feet below the ground, but it probably was one of the reasons that Quadrilla Resources had to abandon the site, which is not very good for them. So it looks like United Kingdom, not on any major fault lines, but nevertheless land that is highly fractured, is a sort of place where earthquakes are likely to happen. Now then, not necessarily, in fact probably not of the level in Oklahoma, the sort that will actually cause damage, but I don't think there's anything wrong with objecting to technology that causes the ground to shake. I think that's a perfectly valid reason to not want it. But anyway, that's just really, I suppose, just a matter of choice. Is there any reason to ban fracking that is not a matter of a choice, that is actually a really serious concern? Well, yes, there is, but this is the part of the presentation where evidence becomes much harder to find. So let's start with a story. This is the small town of Dish in Texas. It used to have a different name, then they did a deal with a satellite television company. Oh dear. Anyway, 225 people live in Dish, and there are 60 fracking wells there. The town is surrounded by them, and the locals say you know when they're in use. You can see them, you can hear them, you can smell them, and if you're the Tillman family, you'd notice because of the terrible nosebleeds their children suffer, leading to the, really horrible story down there in the bottom left. Now, Calvin Tillman was actually the mayor of Dish until he left town. He felt it was the only thing he could do to, look after his children. Bill Cisco, bottom right, quote there, he was also the mayor of Dish, and look what he said: get out of town as quickly as possible. So when the mayor tells you to leave, and that probably means leaving your house, which may have lost almost all its value, you know the situation is serious. But these are just stories. I said I was going to give you evidence. What is the evidence here? But anyway, these stories are anecdotes. And as a famous quote, the plural of anecdote is not data. Though it's actually a misquote, the original version said the plural of anecdote is data. And there certainly are an awful lot of anecdotes like this. The Pennsylvania Alliance for Clean Air and Water looks after something called the List of the Harmed, which currently has 21,700 entries on it, people whose health or property or livestock has been damaged by fracking. Anyway, back to Dish though. The people there were not content to simply be another anecdote about the dangers of fracking. So they commissioned a company called Wolf Eagle Environmental to do a survey, to actually produce some actual evidence. And what they found in their excellent report was, yes, there was air pollution in Dish, including carcinogens and neurotoxins that were of a level that should be considered harmful, of a level that would be consistent with the sort of health problems that people in the town experienced. Can they prove that the health problems are caused by fracking? No, because, well, you can read it for yourself there, because that sort of study takes 20 years. So this is the choice we've got. We wait 20 years to find out whether fracking in the United States really has caused an epidemic of ill health, or we make a decision based on the evidence so far. But that's not the end of the evidence. In Dish, they were just looking at the air. What everyone wants to know is what about the water? Because after the earthquakes, the one thing everyone knows about fracking is it contaminates the water. Or does it? Well, now this is a tricky area. First of all, don't worry too much about that film footage from Australia, the river catching fire. That was coalbed methane, which is similar to fracking but not exactly the same, and that certainly is a lot worse for methane contamination. That's the actual gas itself getting into water and causing it to catch on fire. Now that certainly does appear to be happening around fracking wells, hence the rather unusual advice in Pennsylvania, people not to take showers near naked flames. But what else gets into the water? Particularly, do any of the rather nasty chemicals that get mixed in with fracking fluid end up in the water and hence in you? Well, there's certainly plenty of anecdotes, but once again we need to move beyond that onto evidence. And the American Environmental Protection Agency said they were going to do that, with a massive 5-year study looking at all the evidence to come up with some sort of final conclusion: does fracking contaminate the water? And in June 2015 they came up with their answer, which was this. They did not find evidence that these mechanisms, meaning fracking, have led to widespread systematic impacts on drinking water resources in the United States. So there we are, hallelujah, we don't need to worry about the water, only the air pollution, the earthquakes, the noise and the road traffic collisions. Well, was that the full answer? Well, don't take the answer from me. Listen to their own scientific advisory board. This is the EPA's own in-house scientists who have the job of peer reviewing all EPA publications. And after looking at the draft report for a year, they said this. They are concerned that the findings are ambiguous and appear inconsistent with the observations, data and level of uncertainty. In other words, the EPA had made that claim, but in its report it has singularly failed to prove it. Moreover, they appear to have ignored the rather obvious evidence of water contamination, dangerous water contamination, widespread water contamination contained within the actual report itself. Not that most people will read that, they just published the headline figure. So what had actually happened here? What went wrong? Well, as ever, there are multiple answers, including, well, these two rather interesting quotes for a start. The first one was obtained by Greenpeace in a Freedom of Information request. It is an email to CHK, which is a fracking company, Chesapeake Energy, saying, please write in, you guys are part of the team here. Well, we don't know what Chesapeake Energy wrote back to the EPA, but obviously what we do know is that the industry was in part wrote this report. And then there's the second quote. Right, now then, needs a bit of background here. What the EPA wanted to do as part of their study was find a place that was going to be fracked and study the water before, during and after fracking. That way you get an idea of what changed, because there aren't really any baseline studies in America, no studies of what the place was like before it started getting fracked. So they identified a place, the EPA found somewhere. They were going to move in and take their baseline readings when unexpectedly CHK moved in early and started drilling. And the EPA looked elsewhere, but in the end they never actually found anywhere. They never actually did that part of the study. Now then, this is where cynics like me see a pattern. A regular pattern whenever industry faces regulation by the government. It's part of a 3-point plan. Number 1, you pledge full cooperation. You'll say, we are the good guys, we've got nothing to hide here. Number 2, as you're on side, you get full information of what's going on. And that comes to part 3. You use that information to throw as many spanners in the works as possible. And that's very much... The thing is, the Scientific Advisory Board didn't just say the EPA should have looked harder to find some evidence. It also said it ignored the evidence that was actually in their report, which included 151 cases of fracking chemicals being spilled or leaked and contaminating surface water. The EPA did not know whether this contaminated groundwater, or it certainly didn't know that it hadn't. Also, these were just the cases that they knew about. The EPA actually says that. It actually says they do not know how many in total might have occurred. And this sort of massive underreporting is quite evident if you look at Pennsylvania. 271 cases of water contamination. Not necessarily all caused by fracking. You'd need to investigate each one individually to get that answer. But more importantly, another 2,309 cases were found when people looked into the files of the Department of the Environment. These were cases that had been reported, but the report had somehow got lost and not made it into the main study. So we really have a very small tip of a very large iceberg here. What's more, if you go on, the EPA identified over 1,000 different chemicals used in the fracking process. Chemicals that mostly were quite unusual, ones you wouldn't normally test for when testing water purity. And a lot of them, the EPA doesn't actually know what they do, or more importantly, doesn't know how dangerous they are. Now then, you must remember that thanks to our modern lifestyles, we have traces of myriads of chemicals in our bodies, mostly at very, very small levels that we think, or at least we hope, aren't dangerous. Because whenever dealing with issues like this, you must remember the words of the 16th century alchemist Paracelsus, who, to paraphrase him slightly, said, "The poison is the dose." But if you don't know what a dangerous dose of a chemical is, because you don't know its own properties, you don't know whether the trace, the amount you find in your body, is dangerous. So you have a situation where the EPA simply is unable to tell you whether this contamination is dangerous, or how dangerous, or whether it's something we should worry about. And remember their words in their headline quote there, widespread and systematic. 9.4 million people within a mile of a hydraulic well. Does that mean if 1 million of those people had their water contaminated, it would not be widespread? Over 6,000 water sources nearby. Would that mean if 1,000 of those got polluted, the effects would not be systematic? The suggestion is the EPA, with a headline quote there, were just playing with words, that there is evidence of water contamination and there is evidence of it being harmful to health. It simply seems as a case of none so blind as those who do not wish to see. But don't just take my word on this. Look at the people with more qualifications in the subject than me who've looked at all the evidence. The Concerned Health Professionals of New York, the charity MedAct, and our own British Medical Journal. And although we have to bear in mind conclusive evidence is a couple of decades away, on what we know so far, they have concluded the evidence is overwhelming. Significant health hazards. The arguments against fracking on public health are overwhelming. Certainly the state of New York thought so, banning fracking purely on health grounds, not environmental or anything else, purely on the danger to the health of their own citizens. Which brings us to the next question. Why has the experience of fracking in America been so ghastly? Are the fracking companies in America simply criminals? Are the regulators totally negligent? Is the regulation adequate? Is the technology inadequate? Or does it point to a somewhat more fundamental problem with the industry? Well, there's certainly evidence for each of those points. There is, for example, the story of Hector Zertuche, a deputy sheriff in Texas. Previously, his job was basically fly tipping officer. He'd go out at night and try and catch the people dumping their sofas by the side of the freeway. But once fracking arrived, he suddenly wasn't worried about that anymore. He was catching fracking lorries, several every night, simply dumping waste fracking fluid on the road. And they'd get a fine, and they'd apologise, and they'd say, must have been a terrible accident, we left the valve open, and the next night he'd go and catch a lorry from the same company doing it again. All the evidence being simply criminal negligence in the way they get rid of the fracking fluids. And regulations, well, they're certainly poor. There's also a lot of effort going into stopping people actually enforcing them. In Wyoming, for example, it is a crime to collect photographic evidence with the intention of prosecuting someone for an environmental crime. So if you're walking through a national park and you find someone's dropped a beer bottle on the ground, you snap a photo and send it to the park rangers, you've broken the law. Similarly, if you come across a giant oil slick and you take a picture and send it to the EPA, you've broken the law. So when all the effort goes into making sure companies don't even have to obey the regulations they've got, it certainly is. But that probably doesn't explain everything that's gone wrong in America. Ultimately, you probably cannot stop wells failing. You probably cannot stop accidents, because this is an industry operating on a tight budget, on a tight time scale, in people's backyards. Things are going to go wrong, and those things are going to affect people. It appears to be an intrinsic problem with the industry. And perhaps fracking is actually no worse than any other industry. I've worked in factories, and most factories I've worked in, there's been something somewhere that's not been working properly, and quite often you've had to resort to gaffer tape to fix it. And this photo taken at Ellesmere Port 2 years ago, the iGas test drill, shows that the fracking industry is just like that. If necessary, they resort to gaffer tape to fix things. Do you want that in your backyard? I don't want it in mine. But what about the gold standard regulation we're going to have in the UK? This will keep us all safe, surely. David Cameron, who you may remember used to be Prime Minister, said our regulatory system is one of the most stringent in the world, which would be very reassuring if he hadn't just said, well, almost exactly the opposite 3 months earlier. Now, with politicians, you have to say their actions are rather more reliable than their words. So what has been the government's actions since David Cameron said that? Well, they have consistently blocked EU regulation to make fracking safer. And that is EU regulation, by the way, meaning, of course, if the dreaded Brexit happens, it will become British regulation, and a government minister can probably change it in an afternoon. They've also introduced the infrastructure bill, which largely bypasses the need for local councils to approve fracking. The government can just say it has to happen. But what's more, the infrastructure bill effectively redefined fracking, so that nearly half of American fracks wouldn't actually count as fracks, and hence they wouldn't even have to follow what EU regulation is left. This gold standard does look pretty tarnished. It's hard to see that David Cameron's words are matched at all by his actions. And that's not the only actions the government's done in regards to fracking. The government produced a report on fracking which listed many of the possible harmful effects of it, including the effect on house prices that we've not really mentioned so far. But they managed to keep it quiet. They ignored 16 Freedom of Information requests by Greenpeace, and it only appeared 2 days after the crunch vote by Lancashire County Council to approve the UK's first commercial frack. Now then, that vote was actually to oppose fracking. Lancashire said no, despite not being able to read the report. But the government decided they were going to intervene, and they overruled it and said fracking is going to go ahead in Lancashire. So, as well as watering down the regulation, government is also prepared to bulldoze local opposition to fracking, local democratic opposition to fracking. So once again, actions rather than words. But again, don't take my word for this. Listen to some people who actually know more than me. Michael Hill, for example, worked for the EU Commission and says we do not have gold standard regulation. We have regulations that aim to make fracking easier for the companies rather than safer for the public. And then there's Elizabeth Reep, who more or less says even if we did have gold standard regulation, there are risks that regulation cannot remove. Good regulation will undoubtedly make fracking safer, but I don't think it will ever actually make it safe. What's more, that whole question is really an academic one, because in the real world we have the regulations the fracking industry wants. So to summarise this first part of the presentation, the experience of fracking in America has been devastating. And what's more, the evidence is, if it comes to this country, we'll be looking at something pretty bad. It will industrialise the landscape. It will increase road traffic in rural areas. It will put you at risk from air pollution and road traffic collisions. It will cause earthquakes, though how serious and how many we don't really know. It will pollute the air. It will probably pollute the water. And those two things together will undoubtedly put your health at risk. This is not something you want going on in your backyard. And for 2/3 of the people in England, that is a very real possibility if fracking goes ahead. But carrying on, because this is a presentation in 2 parts. And before I start part 2, what I'll say is, forget everything I just said in part 1. If part 1 is what happens if fracking goes wrong, part 2 is what happens if fracking goes right. Part 1 is why fracking should be unwanted. Part 2 is why it is very much unnecessary. Like everything, fracking has a cost. It certainly has a cost in terms of water. 10 to 30,000 tonnes of clean water per well. It's also worth mentioning that conventional power stations use up to 250 tonnes of water an hour, so they consume water almost as fast as they consume fossil fuels. And whilst we know how to replace fossil fuels, we don't yet know how to replace water. But that's not the only problem. The water, which was mixed in with the chemicals when it was pushed into the ground, comes back out again, at least about 1/3 of it comes back out again. And that's probably going to have to be classified as radioactive waste, because there's an awful lot of radiation down there, as well as heavy metals and other stuff that you want to get rid of. You can't just put this wastewater into an ordinary sewage treatment plant, you have to basically build a special one. And, well, how big this problem is largely depends on how large scale fracking gets in this country. But broadly speaking, you're looking at a cost in clean water and a cost in water treatment that's more or less the equivalent of adding an extra city to the United Kingdom. That is not nothing, but it's hardly the main problem. This is the main problem. Climate change. Forget Brexit, Trump, Syria, and strictly, this is the big issue of the 21st century. This is the issue that will decide what sort of world our grandchildren live in. Now, you've probably all seen this, the graph of doom. This shows that our consumption of fossil fuels has led to an increase in global temperatures by about 1.1 degrees on pre-industrial levels. It also shows that if we carry on with a business as usual scenario, we're looking at temperature rise of about 4.5 degrees. By the year 2100, maybe even 6 degrees. That is greater than the difference between the present day and the last ice age. A 4.5 degree world will be one almost unrecognisable. Parts of Europe will simply be too hot for human habitation. Farming may only be possible in the subpolar regions. This is a world changed beyond all recognition. Now, it's difficult to say what a safe degree of climate change would be, but most of the really bad scenarios start at about 2 degrees. So the conclusion is it's imperative that we keep warming by the year 2100 to no more than 2 degrees, preferably less. And that means some rather fundamental things about the way we consume fossil fuels. Now, politicians are quite fond of setting targets for our fossil fuel use in the future, preferably the future long after they've left office. For example, our Climate Change Act says that by 2050 we'll be using 80% less coal, gas and oil. Now, that's important, but rather more important is how much fossil fuels we use between now and then. This is our carbon budget. Now then, if we want to avoid that scenario of a world warmed by more than 2 degrees by the end of this century, we have to stay within a strict carbon budget. The projections are basically we can carry on as we are for a couple of decades, after which, stop. No more fossil fuels can be used ever again. If you want to go for the safer scenario, a world warmed by 1.5 degrees, then we have less than 10 years. Or put another way, how much of the coal, gas and oil we know about in conventional reserves can we use? Well, that's the graph on the right. The red circle is the conventional reserves we know about, the black is how much we can use. 1/4 to 1/3. That is our budget, and if we do not stick to it, our grandchildren will inherit a world that is uninhabitable for human beings. So what should be immediately obvious from these graphs is that there is no room for any new fossil fuels. We already know of more than we can possibly burn, so we don't need to start looking for new stuff. But not all fossil fuels are bad. They aren't all equally bad. Gas, whether it's shale gas or natural gas, for example, produces 50% of the carbon dioxide emissions of coal at the point of combustion. So there is an argument, and you hear it quite a lot, we should be exploiting shale gas in the short term as a sort of low-calorie stopgap until we can properly get off fossil fuels. But, well, there are a few questions that come from this. Starting with, can we do a lot better than 50%? Now, the Finnish energy company Vattenfall did a survey. Vattenfall, I should point out, owns an awful lot of brown coal. It's a company Greenpeace has campaigned against, it's a company I've campaigned against. So they aren't really the natural cheerleaders to the renewable energy, but it's a good survey. And this is what it showed. Studying these power sources over the whole of their life cycle, it found natural gas has 64% of emissions as coal. Good, about a third better. But look at the others. Biomass, 2%, wind, 2%, hydro, 1.2%, nuclear, which has a few of the downsides, I must admit, 0.6% in terms of carbon dioxide emissions. Now, they didn't study solar as it wasn't really widespread enough, but from other sources we can say that solar would come out about 3.5% on these figures. What's more, these alternatives exist. You can buy solar panels on eBay, you can build a wind turbine whenever you want. Fracking doesn't exist. We're talking 5 to 10 years minimum before it gets off the ground. But that's not the end of the problem. Remember the crucial phrase at the end of that last slide? At the point of combustion. Because whether fracked gas is 50% better than coal is very, very doubtful indeed. Now then, shale gas is 90% methane. The other 10% are interesting ones. They're the volatile organic compounds. They're the ones that are probably causing some of the health effects. But let's just worry about the 90% of the methane. Now, methane is a greenhouse gas. Like carbon dioxide, it gets into the upper atmosphere and it traps heat. What's more, it is a more potent greenhouse gas than carbon dioxide, 105 times more potential for trapping heat than CO2. Now then, it doesn't last as long, only 12 years in the atmosphere, whereas carbon dioxide is between 30 and 100 years. But put those two things together and the potency of a 100-year time period is 34 times that of carbon dioxide. That may be an underestimate, by the way. There's some evidence that methane is linked to ozone and air pollution, which actually magnifies the effect. But let's stick on the figure of 34 times more potent, which is used by the International Panel on Climate Change. What it means is, if only 3.2% of that methane leaks, in other words, doesn't get burnt to form carbon dioxide, it escapes directly into the atmosphere, then that negates the 50% bonus over coal when you burn fracked gas. So the question is, the million-dollar question is, how much methane leaks? Well, the simple answer is we don't know. The estimates have swung wildly from one extreme to the other. First of all, the figure was 3 to 8%, then it went down to 0.5%, then they did another survey and discovered that they've massively underestimated it, for a variety of reasons. I mean, there were sensors that weren't sensitive enough, people not looking in the right place, and, well, possibly some of the institutional problems of the EPA we looked at before. But what we can conclude is the issue of methane leakage at least partially negates any benefit shale gas has over coal. It may even completely negate it. It may even be that fracking is actually worse than digging up coal. Where does this methane leak from? Well, all sorts of different places. It comes out of poorly secured well shafts, it comes out of old wells, it comes out of storage facilities, it comes out of almost every stage of the US natural gas system. In fact, the result is there is a methane cloud over the southeast United States that can be seen from space, one that certainly wasn't there 20 years ago. Also, you can fly over the fracking areas of the United States with an infrared camera and you see methane coming out of all sorts of different places, like that picture of the tank on the right. So methane leakage is almost certainly underestimated. But even if it is correctly estimated, it is a big problem that makes fracking barely better than coal, if not worse. But even if you ignore these fugitive emissions, fracking is only better than coal if that coal stays in the ground. Now, has it? Well, first of all, here is a graph showing US coal generation over the last 18 years. As you can see, fracking starts to come online beginning of this century and US domestic coal use plummets. But that's far from the full story. Look at this graph. The orange line is US domestic coal production. Slight dip, but more or less staying constant. The blue line is US coal exports. Once again, fracking starts big time, start of this century, and US coal exports suddenly start shooting upwards. That coal is not staying in the ground. It is simply being sent abroad to be burnt rather than being burnt in the United States. Now there may be a happy ending to this story. This year, 2016, Peabody Coal went bankrupt. Peabody was the world's largest private coal company, sort of thing that makes environmentalists throw a wild party. And the reason it went bankrupt, well, not enough people were buying their coal. In particular, the Chinese weren't buying as much as they thought. Look at this graph. The two black dotted lines are Peabody's projections for how much coal China was going to buy off them. The solid white line is how much coal China actually bought off them. The reason? China may well be using less coal. It may have reached peak coal. Well, why? Well, it used to be the case that China was building a coal-fired power station every 2 weeks. Not anymore. Now it's more accurate to say China is building 2 wind turbines an hour. They're also the world's largest manufacturer of solar panels. Perhaps too early to say that China is on the way to giving up coal, but there's certainly signs that they are stopping their rush to coal. And the reason is not fracking, it's renewables. Now, in my opinion though, those 2 points are not the main problem with fracking and climate change. It's this: infrastructure lock-in. I've tried to avoid too many jargon terms in this presentation, but this is one I couldn't really get round. What does it mean? Well, think about this for example. Imagine you're a company that makes inefficient gas guzzling cars. In 10 years' time, a car bought today will be on the scrap heap. Maybe someone can buy a better one. On the other hand, what if you're a company that makes drafty, inefficient houses? In 100 years' time, someone will still be living in that house. So it's probably more important that we have regulations for warm houses than for fuel-efficient cars, at least in the short term. That's what lock-in means. It means things we build today will still be in use in the future. How does it affect fracking? Well, for this reason. In order to burn the fracked gas that we plan to produce, the government has announced 30 new gas-fired power stations. Those power stations will have a lifespan of 25 to 30 years, meaning they will still be in operation in 2050, by which time, even if the optimists get their way, there will be no fracked gas coming out of the ground in this country. The fracking boom will have been and gone if it ever happened. So that is why it is vitally important we stop fracking in this country now, because the decisions we make over the next few years will decide whether or not that 80% reduction in fossil fuels by 2050 of the Climate Change Act is possible, or whether we will still have a network of gas-fired power stations producing carbon dioxide that causes climate change by the middle of the century. Decisions taken today will have big consequences. That is why fracking must be stopped. But what if we don't frack? What do we do instead? Well, we do lots of different things. Greenpeace produced their report, Energy Revolution, which looked at power generation globally and showed how by 2050 we could stop using fossil fuels and, without the use of nuclear power either, go entirely renewable, in the process creating 16 million more jobs than if we carried on with the business as usual approach. Trade union group of the Campaign Against Climate Change, looking just at the UK but looking at all aspects of energy use, reckoned we could create 1 million climate jobs directly here in the United Kingdom, by everything from renewable energy to public transport to more fuel efficient homes. In fact, what both these reports show is whatever we do instead of fracking, however we produce energy or however we save energy, it produces more jobs than fracking, and what's more, it's possible. As I said, fracking isn't yet here in the United Kingdom. We could be 5 to 10 years away. The alternatives are here. Well, I haven't got time to go into all the exciting things that are happening, but here are 2 that interest me. Remember how efficient those Scandinavian hydro schemes were in that Vattenfall study? Well, very soon there'll be an electricity interconnector between here and Norway. What that means is we can send our electricity to them and they can send theirs to us. What that means in practical terms is, if, for example, we build a whole lot of wind turbines, and we've got some of the best wind resources in the world, we could build wind turbines all around our coast, and when they work in the middle of the night, when no one's using any power, and we get more electricity than we need, we can send it to Norway. They can then turn their hydro skis backwards, pump the water back up into the reservoirs, meaning come the evening when we need more power, when perhaps the wind drops, they turn them on again and send the power back to us. That's one way of making renewable energy work. Another way is one on the right, a smart fridge. Now, one of the big problems with an electrical grid is dealing with surges. I mean, I think traditionally it used to be the ad break during the Saturday afternoon James Bond film, and of course the World Cup and other big sporting events cause a problem. So imagine a scenario: it's the 2022 World Cup. England are in the final, about to take on Germany. It's gone to penalties. The last shot is taken, it flies over the crossbar, and we're out. 5 million disgruntled football fans go into the kitchen and turn the kettle on, causing a power surge. Well, just imagine if at that very moment every fridge in the country receives a signal telling it to turn itself off for half an hour, smoothing out the surge and keeping the grid going. And that's the sort of thing that's going to happen in future. Smart devices operating in smart grids, all adding up to smart solutions. Things that keep the lights on without requiring fracked gas or any sort of gas or coal or oil. And that's what we're going to have to do if we're going to use our ingenuity that we've been given as human beings to beat this really fundamental problem of climate change. Fracking has no part in that. So that's my case against fracking. It's either a toxic nightmare waiting to happen, or it's a cause of climate chaos, or it's most likely both. It's also the roadblock to us doing the things we need to do, the smart solutions, the clean solutions, the solutions that will give us cleaner air and more jobs and warmer houses, the solutions that will keep the lights on and the planet cool. Fracking has no place on this planet. So if you're not already part of the campaign against fracking, please join it. We're nice people, we'll make you very welcome. What's more, you'll be part of the growing movement to give us these very solutions that we want. Stopping fracking comes first. Green energy comes second. Saving the planet will be the result. And if you want to know more, I would recommend these 5 reports, all of which are available free of charge on the internet. The case against fracking is building all the time. There will be more reports. Watch this space. But in the meantime, thank you very much for listening. My name is Martin Porter, and that was The Case Against Fracking. Thank you.